Our closing talk is going to be presented by Cekouat León Peralta, and it is titled Unfolding Orchid Diversity Through Paper Folding.
Okay, so here I am again. And first of all, I want to say thank you to the organizers of these conferences for accepting such an unconventional talk. However, I didn't want to miss this chance to spread and to promote the way that I have been using for the last decade to approach not only orchid diversity, but in general, floral and animal diversity that we have in this planet. So for those orchid folks around here, do you recognize what kind of flower is this? Exactly, thank you. So orchids have inspired people for hundreds and thousands of years. In the last 2 centuries in particular, many artistic expressions have been extraordinarily fit by the diversity found in the orchid family. I think we all, with taxonomists, find a lot of inspiration in this scientific illustration. Also, as we know, many types of many species are actually illustrations like this that were initially inspired by classical illustration. Orchids have also inspired sculpture, literature, and even music. I really recommend you to check this project. Basically, they used genomes of orchids to produce music. It's very interesting, so you should look at things like this. But there's also paper folding. In the last 20 years, people have been making origami flowers that represent orchids of very different groups. And among the many examples that I could show you, I choose these 3 ones because these marvelous works of art have been displayed in museums all around the world, but they are not made properly by artists graduated from different colleges in art. They are actually scientists. Robert Lang is a physician. He worked for many years for NASA, and he is currently applying origami to deploy solar arrays in the space. Adam Cham from Vietnam, he's actually a chemist, he's a professor, and Michael LaFosse is a trained marine biologist. But all of them use paper to represent and to understand biodiversity in general, and in particular of orchids. But let's come back one step. What is origami? Origami is the Japanese art of paper folding. The name is composed by 2 words. Oru, that means to fold. Sorry, I didn't translate those. Kami, that means paper. So origami means literally to fold paper. And this work, which was published in 1797, shows that people in Japan used to fold paper cranes basically to play around with kids. But origami has changed a lot, and it's been thanks to geometry. We start with a square of paper. And here we find 2 kinds of folds. The red ones are valleys, and the blue one is a mountain. How does this operate? If we fold a paper just like this, what we have is that the 4 corners of the paper collapse into a single point, while the center of the paper becomes a flap. If we add 1 more valley fold here, what we have is that each of the ridges, horizontal and vertical, of the paper meet in one center, so that each of the 4 corners are independent flaps. But what if we add some angles to the edges of the paper? For example, here I added 22.5 degrees. And this way, we can have the same 4 flaps, but they are thinner this time. As you can see, everything folds together, but instead of having these large triangles, we have narrower triangles. Notably, the center of the paper becomes a rather small flap that is here, okay? So, if we add more angles to the edges of the paper, we have the same 4 large flaps as well as other 4 smaller flaps. So basically, it all works by adding angles to make new numbers of flaps. But this arises a question. What portion of the surface of the square is used by a single flap? Because let's think, if we want to fold something that has only 4 flaps, we don't want to waste more space in other features of the model. So what scientists found is that each flap, if it's folded by this distance, and you unfold the paper, you have these creases. If you fold a narrower flap and make the same crease, you have these creases. But what happens if you have a super tiny flap, just like this, and make the same crease? You have a segment of a circumference. In particular, as this flap was made from a corner of the square, we have a quarter or a circumference. And this changed everything, because now, if we fold the flap from the middle of the square, we have half of a circumference. If we fold the flap from the center of the paper, we have a full circumference. So, if we want to fold many flaps, we need many circles. Basically, this is an origami bow plan. And if you remember, in biology, a bow plan is this structure and organization of organs or tissues that define an organism. So these are the very traditional origami models that are folded in Japan since a lot of centuries. And here you can see stick figures that represent each different flap. And here you see the circles that are packed into the paper that can be folded this way to make the finished figure. So if we want to fold, let's say, an orchid that has 6 independent organs or flaps, we need 6 circles. Let's take a Cekouat orchid. We have, pretend you didn't see that. We have a dorsal sepal, 2 lateral sepals, 2 petals, 1 lip, and 1 column. And the shape that provides us with the required flaps is actually, a hexagon. And as you can see, here we have 6 portions of circles and 1 in the middle. This way, we can get all the features that a flower has. And if you use a beautiful handmade Japanese paper that is green on one side and white on the other, we can actually fold a Cekouat flower from an hexagon of paper. But if we want to get an orchid with a similar structure in general, but with a very slightly different identity of each of the flaps, we can make, for example, a Peralta flower. In this case, the central flap that was the column is the ovary, while 1 flap is used to make the color change. In this case, one side of the paper was green and the other was black. And as you can see, I used the center flap to make the ovary. This is a hexagon. And you may think that actually this is the most straightforward way to approach orchid morphology, because in general, this is a very repetitive structure and motif. But orchids are more complex, and we want to make our life more complex. This was easier. And to approach the morphology of sleeper orchids, I decided to reduce it to the simpler morphology. So in this case, we have a dorsal sepal, a synsepal that is actually hidden behind the lip, the lip comes to the center flap. These two smaller flaps are used to make anthers, and these two small flaps are used to make the ovary that is hidden behind. If we add these strips to the paper, that is not physically, but in terms of the geometry, we can fold a more rounded lip. This one was folded from a Japanese paper that was very thin, and the flower is actually the real size. But this, in this case, as you can see, we can manipulate extra portions of paper to add details, to add extra features, and to make a specific species. And I said, well, what about making a phragmipedium with long petals? In this case, I modified the shape of the original square. What I did was to hit these two opposite corners. And from these two corners, I got the long, long petals. From the center, the staminodum that is here. And from this point, the lip. And these corners are actually the sepals. My message here is that just by understanding the simple rules of folding, we can represent any plant that we want. I came up with this base a couple of years ago because I thought, well, maybe by following this logic, I would need a particular structure to represent each different species of orchids, right? But this structure allows me to make different orchids from a similar geometric bow plan. So, in this case, we have an Encyclia cordillera orchid. This dorsal sepal is represented by this flap. The petals that are thicker come from these middle flaps. These dorsal sepals come from the corners of the square. And if I want to make a lip that is of the opposite color, then I need a longer flap. These small flaps that are actually ridges that come to the edge of the paper become the lateral lobes of the flower. In this case, this wasn't very efficient because you have too much paper here. But if we change the structure, we can make something a little more complex. In this case, I used this flap to make the long nectary of Angraecum sesquipedale. And actually, from this base, it's very straightforward to modify it to make other kinds of orchids. By splitting this flap in 3 separate flaps, I can make this Stanhopeia that has a more complex lip. In this case, the sepals that have more paper are distributed here to make the petals that are backwards. And for these Coryanthes, I decided to use the same grafting pattern to make the longer petals, and why not to add a small pollinator. Making these patterns requires some time, but in the end, it has been very useful for me, not only to understand and to develop my need to do some art, but it also has allowed me to share and to teach. I've been very fortunate to have the space to teach origami to people from children to seniors, like here. And it's wonderful because just by folding paper, you can teach people floral morphology, even ecology, if we fold a flower and a pollinator. For example, in this case was very special to me because I traveled to Spain, and in Spain, people are not really into orchids because most local orchids are terrestrial, they are small, and the only orchids they have available at floral shops are Phalaenopsis or Dendrobium. So when I talked to them about the beautiful Cattleya flowers, they were amazed. And this is very important because the first origami flower that I folded was a Cattleya back from 10 years ago. So I got into orchids thanks to origami, and now it's my responsibility to come here to talk to you about origami. And well, art gathers people. Orchids gather people. So for me, it's been very special to connect with different cultures to talk about this. And I was very fortunate as well to present an exhibition focusing on origami, hummingbirds, and orchids in Spain. It was a wonderful event, although I had to fight a lot because they wanted to put this hummingbird next to Sanupia. I couldn't correct the graphic designer, but, well, nobody's perfect, right? But this was amazing because the exhibition gathered 1,000 people on the first day. And I received very nice comments from Latin American people who have lived in Europe for decades, and they had not seen orchids or hummingbirds in many years. So eventually, art is a way of connection, right? So I just wanted to show you this example because by sharing art, we can make people aware that orchids, as well hummingbirds, exist, that they have an important role, and that they are very diverse. This was my favorite panel from that exhibition with Acatleya, of course. And if you want, you can scan this QR code to see the full catalog of the exhibition. It consisted of many orchids and hummingbirds, and it's for free. So if you want, please make a visit to the catalog. And you can actually scan again this code to find some instructions to make a Lycaste orchid and an Encyclia orchid. I recommend you to start with the Lycaste because it's easier, but eventually I hope you will be able to fold your own Encyclia orchid and to make your own variations. So that's it for me. I hope I had to have convinced you that paper folding is actually a good strategy to study orchids, to share orchids, but at the end of the day, I think if we can use art, in particular an art that is both traditional and sometimes focused to children, this is something that we can just turn around and to use it for science, to incorporate geometry, and by the end of the day, to make people aware that orchids have an important role in our planet. So you can contact me here, and please make a visit to the website. I have more information. And if you want to have this orchid exhibit in your institution, please reach out. I will be very happy to share with you all. If you want me to design specific plants or orchids or whatever you want, I can also do that. And that's all for me. Thank you.
We have time for questions.
Just a comment. I'm impressed, and I think we all are. I am very passionate about art and science, and you are an artist and a scientist, and coming together these to make conscious about the importance of the natural patrimony that people have around them. So congratulations, and thank you for sharing this amazing talk.
Thank you. Thank you so much.
Hello, I'm from Japan, actually. As Japanese, I was very surprised. I'm ashamed to not knowing you. Do you have some exhibition in Japan too? Have you?
Well, unfortunately, not yet.
Okay.
But I'd really love to. I'm always looking for programs to exhibit in other places. Japan has been actually kind of difficult because there are only a few institutions that have actually pushed origami to further limits. But there is actually one, the Origami House in Tokyo
Uh-huh.
that publishes a lot of books and hosts the Origami Convention in Tokyo.
Yeah.
So I really hope to go there soon. And if you, but on the other hand, to me, it's been very important to connect botany and the arts. So to be honest, it's been easier for me to contact universities and faculties and, in general, scientific institutions than artistic galleries and something like that. Origami still has a long way to go to be recognized as a formal art, but I hope that we get there slowly.
Okay, just an information. In our university, we have a large group that has a love in origami as well. So maybe I have a friend in that group, so maybe you can give it.
You're my hero.
Yeah.
You're a hero. Thank you.
Thank you for your beautiful presentation.
Thank you. Thank you. Thank you.
Another question or comment?
Thank you, Cekouat, for the amazing presentation. I'm amazed at how you produce those softer curves.
Yeah.
Because on your diagrams, you make it seem very easy, right? But the edges are very sharp. You don't only follow those lines, right? You make further folds, right? I guess,
Yeah.
to produce those softer curves and give the shapes the particular, more naturalistic appearance.
Yeah.
It's more
In
complicated
general,
than that, then.
yeah. In general, origami consists of two phases. One that we call a collapsing, that is folding everything you have here in this crease pattern. That is how we call this. And on the other hand, once you have the bases, the base, the geometric shape, here comes the artistic side in place. Because in the first place, not all papers work for this kind of pieces. And on the other, papers in general have to be treated to be able to get to these shapes. So I use handmade papers, especially from Japan, also from Korea and from Vietnam, and more recently from Mexico. And I use methyl cellulose, that is a chemical compound that helps me to basically to strengthen the paper and to confer a more solid appearance. So yes, once you have the geometric shape, it takes a long time to get to the final shape. It takes a lot of patience. And just to finish, I want to come back to the model that actually introduced me to orchids. That is this one by Michael Lafosse. This cattleya was folded from an uncut rectangle. And what makes the work of Michael special is that he moistens the paper. He uses a technique he calls wet folding. So once the paper is wet, you can carefully configure the shapes you want. And when it's dried, it preserves the shape. So Michael is an expert in this technique, and if it wasn't because of this particular flower, I wouldn't be here.
Another question or comment? Okay.